Okay, so this overall section is talking about the quadratic equation. In this video, we're going to talk about solving quadratic equations by factoring. But just to remind you what a quadratic equation is, that's an equation that contains a second degree polynomial. So not a third degree or fourth degree, so quadratic, quadrus means square, so a second degree polynomial. So something of the nature like ax squared plus bx plus c equals 0 is an example. So factoring is finding the expressions that can be multiplied together to give the expression on one side of the equation. Factoring is one way to solve a quadratic equation. That's going to be the focus of this video. Now, this is a very underrated property, the zero product property. People think, of course, if a times b is 0, then a is 0, b is 0. That makes sense. But it really gives us a lot of power that if we can set one side equal to 0 and then factor the other side, one of those factors, set each factor equal to 0, then by what is a solution? It's a value that makes the statement true. And so we're able to find values that would make the statement true by making either one of those factors equal to 0. Actually, we'll find both. So there might be more than one. Might be 1, might be 0, might be 2 solutions to these. So solving a quadratic equation with leading coefficient of 1. So if you remember our factoring section, I think that was chapter 2, find two numbers whose product equals c and whose sum is b. Use those two numbers to write two factors of the form x plus k or x minus k, where k is one of the numbers found in step 1. Use the numbers exactly as they are. In other words, if the two numbers are 1 and negative 2, it would be x plus 1 and x minus 2. Solve using the zero product property by setting each factor equal to 0 and solving for the variables. Looks like this one kind of bumped below. So maybe I'll just do this. There we go. Factor and solve the quadratic equations. So this first one, if you remember from the earlier videos, I did like a diamond problem type, so I put -6 on top, -5 down below. So I'm looking for two numbers that add to be -5 and multiply to be -6. I think -6 and +1 does the trick, because -6 times 1 is -6. The -6 plus 1 is -5. So our x squared minus 5x minus 6 is x minus 6 times x plus 1. So we have a product equal to 0. So I could take each factor of the product and set that equal to 0. So x equals 6. X equals -1. And those are two values that would make this original equation a true statement. So x equals 6 or -1. Let's try the next one. I'm going to put -30 up on the top, put -1 down below, because the coefficient for that minus x is a -1. And then we will have, let's see, -6 and +5. -6 times 5 is -30. -6 plus 5 is -1. So that's like saying x minus 6 times x plus 5. So we have x minus 6 times x plus 5 equals 0. So I set each factor equal to 0. X equals 6. X plus 5 equals 0. So x equals -5. So our solutions here would be 6 and -5. Okay, let's keep going, and we're going to use the square root property next. So we have solve. So with the x squared term isolated, so if you have something squared equals a number, then if x squared equals k, then x equals plus or minus the square root of k, where k is a non-zero real number. Also not negative. If it was negative, then it's going to be, yeah, they don't even say that. Then it would be imaginary. So in this problem here, we can isolate this factored side, where the variable is, we have x minus 4 squared equals 5. So now I have something squared equals a constant. So if I take the square root of the x minus 4 squared equals the plus or minus square root of 5. I do plus or minus for the constant part because if you square that negative, the negative squares out. So x minus 4 equals plus or minus square root of 5. Can't really evaluate this square root of 5. Then I can add 4 to both parts. X equals 4 plus or minus the square root of 5. And that's actually two solutions. That's 4 plus the square root of 5 and 4 minus the square root of 5. Now for the next one, I have 2a minus 90 equals 0. I can add 90 to both sides. I have 2a squared equals 90. Then I can divide by 2. So a squared equals 45. Now if I take the square root of a squared, then I would take plus or minus the square root of 45. So a would be, that's 45, not 9. Excuse me about that. Sorry to confuse people. That'd be a is plus or minus the square root of, now 45 is 9 times 5. So I can represent this as plus or minus the square root of 9 is 3 times the square root of 5. So a is plus or minus 3 root 5. Okay, let's keep going on here. One more little part. Using the Pythagorean Theorem, the sum of the squares, if you probably know the Pythagorean Theorem, the sum of the squares of the legs of a right triangle is equals the squares of the hypotenuse, the square of the hypotenuse. So this is the hypotenuse. It's the side opposite the right angle. This is a side over here. So use Pythagorean Theorem to solve the right triangle. Leg A measures 4 units. Leg B measures 3 units. Find the length of the hypotenuse. So that means 4 squared plus 3 squared equals c squared. So 16 plus 9 equals c squared, or 25 equals c squared. So c would be the square root of 25, which is 5. This I'm not going to say plus or minus because you can't have a negative distance. So c equals 5. And then we'll do one more like this. Then we'll get on to the next video. Find the length of x in the triangle. So we have this side is one side's x, one side's 9, the other side's 17. So it'd be x squared plus 9 squared equals 17 squared. So x squared plus 81 equals 289. So we can subtract the 81 from both sides, and x squared equals 208. If I want the square root, that's not a perfect square. So I'm trying to think what might be a good breakdown there. Hang on. So x would be the square root of 208, which is the square root of 16 times 13. So the square root of 16 times the square root of 13, or 4 times the square root of 13. That must be the length of x. The decimal approximation is about 14.4222051. As far as my calculator would take it more places, that's just what the display shows. Okay, so sorry this video is a little long. I know that we want shorter videos, but next one is about completing the square and then quadratic formula.